Okay, gang, today we're going to pick up on another way instead of doing this problem. So if you look back at the last video, the last one I ended with was we were finding the area of this region here where we had to do a breakup, okay? So if you recall, when we broke this up, okay, that's the one where we ended with, and I had all this work here, so we had to break that up at that point right there. So we integrated from 0 to 1, top minus bottom, and the second piece was from 1 to 4, top minus bottom. So when we were finally said and done, this was our setup and this was our solution. Now, an alternative to this is now we can start integrating with respect to y. So instead of the slices or the rectangles sitting from top to bottom, what we can do now is let these rectangles sit from right to left. So I'm going to get rid of this and we'll compare the two. Now, when you integrate with respect to y, we're going to be looking at the function on the right minus the one on the left. So if I come over here, I'm going to use the same example, x minus 2, and this is the curve x equals y squared. And when you want to go over here, check this out. I'm going line minus curve, line curve, line curve, line curve, and line curve. So throughout the entire life of this problem, the line is on the right and the curve is on the left. So in this case, I wouldn't have to break this up. So what I'm going to do is I'm going to integrate with respect to y. All right, and I'm going to do right minus left. Now, if you think back to the one we just did that gave us 9/2, let's check out this one. So I'm going to do this with respect to y. So here's the kicker. On the right-hand side, right now it's in the form of y equals x minus 2. So we have to solve for x. So y equals x minus 2 is equivalent to y plus 2 equals x. So that becomes the function on the right. So now when I do this, the setup will be y plus 2 minus on the left, that's already in the form of x equals y squared dy. Now I don't know about you, but if you compare that to the setup we just had there, this looks a lot more easier. Now the other thing we have to remember is when you integrate with respect to y, the interval is created on the y-axis. So we're going to integrating from this y value to this y value, okay? So the point of intersection here was the point 4, 2, if you recall from the other day. So now when I come back here, all right, I'm going to integrate from -1 to 2. And hopefully when I do this, I should end up with the same answer of 9/2. All right, so let's check it out. So my simple integration gives me y squared over 2 plus 2y minus y cubed over 3 from -1 to 2. And as usual, our bracket, but. 2 squared, 4 divided by 2, that gives me 2 plus 2 times 2 is 4 minus 8/3 minus -1 squared gives me 1/2 minus 2 plus 1/3. So I'm left with 6 minus 8/3 minus, now when you combine these, if you want to go sidebar, we've got 3/6, I'll do this here, minus 12/6 plus 2/6, so that's going to yield an answer of -7/6. 6 minus 8/3 would give me 10/3 minus a -7/6. So we get 26, 2 negatives plus 7 over 6, and we get an answer of 27/6, which is equivalent to 9/2. Now, I don't know about you, but this little setup here is a lot easier than breaking this thing up into two pieces. All right, so new technique, right minus left. Use that when if you don't feel like breaking it up. And again, if you're comfortable with doing the breakup technique, go ahead. I don't care what you do. All right, just be careful. But this seems a little bit more simpler in this case. All right, let's try another one. All right. Example number 2. Now I'll give you a hint. A lot of the times when you see x equals and the function is squared, all right, it's probably going to be, well, I shouldn't say function, the expression y minus 2 squared, it's probably going to be easier to integrate with respect to y. All right, so here's the case. So I want to find the area bounded by y equals 4 minus x and x equals y minus 2 squared. So if I were to do this with respect to x, curve, 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 I'd have to break it up at this point and then line, curve, line, curve. If I look at this in terms of right to left, the line is always on the right, the curve is always on the left. So to me, it'd be a lot easier by doing this with respect to y. All right, let's cut to the chase. First things first, we have to find the points of intersection. Okay? So let's do that quick. Let's not trust the grid, let's assume. Now right now this is in the form of y equals 4 minus x, which is equivalent to x equals 4 minus y. So if I take the x and bring the y back. So to get this point of intersection, I'm going to set these two expressions equal. So let's see. We get 4 minus y equal to y minus 2 squared. All right. 4 minus y gives me y squared minus 4y plus 4. When I create a quadratic, I get 0 equals y squared. That y goes over, becomes negative 3y. 4 goes over, gives me 0. So we get y minus 3. So they will intersect at 0 and 3. So now I know when I integrate, I'm going to integrate from this y value, which is 0, all the way to this y value, which is 3. All right, let's do the setup. Let me get rid of this. And let's see. So here we go. So if I'm going to use the technique of right minus left, we just know now we're going to go from 0 to 3. The right-hand side is 4 minus y, minus the left-hand side, be careful here, y minus 2 squared dy. So that would be your setup. Now the rest is just the rigor of completing. Now I wouldn't integrate now and use substitution. I would probably multiply all this out and combine like terms. So I get 4 minus y minus, be careful with your parenthesis, y squared minus 4y plus 4 dy. So we get from 0 to 3, 4 minus y squared plus 4y minus 4 dy. So we finally end up from 0 to 3. The 4's cancel. We're left with negative y squared plus 3y. Now if you're bored, you can go back and do this one with respect to x. I'm going to see it's a lot busier. All right, moving over. Let's integrate. So we get negative y cubed over 3 plus 3y squared over 2. From 0 to 3. So we get 3's cubed, 27. Negate it, we get negative 9 plus 3 squared, 9 times 3, 27 halves. Love the 0. So we're left with negative 18 halves plus 27 halves. Final answer, if you completed it on your own, turns out to be 9 halves. So that's the last technique. Integrate right to left, everything in terms of y. Make sure your interval goes along the y-axis. All right, have a great day.